Hello everyone, welcome to my workshop. Having a bus-based CNC machine was my dream since I've got interested in industrial machines. I love the modularity of systems where pretty much every component is connected through some kind of bus. Unfortunately, this usually means you have to spend a little fortune to have this. EtherCAT is one of the cheapest options, while Circos 3 is the top-notch one. I don't have such money, but I'm pretty stubborn, so I've decided to build my own bus-based system. This is easily one of my biggest programming projects yet. Everything needs to be synchronized and compatible with each other. Otherwise, the machine in which this system will be installed would be pretty much unusable. As you can see, for now it's a pile of PCBs, wires and connectors, but trust me, it all adds up to a working system. As my data carrier, I've chosen the CAN bus. It's a standard industrial and automotive communication protocol, yet it's robust, cheap and easy to use. Of course, it comes with its own limitations, like a rather low speed of 1 megabit per second and a small frame size of only 8 bytes. There exists something like CAN FD, which is capable of up to 64 bytes, but it's not easily available for me at the moment. The standard CAN bus will limit my machine to 3 axes. For some, this might be a deal breaker, but for me it's just a development process. Once I will get my hands on CAN FD, I'll most likely upgrade my software so the machine can theoretically support up to 31 axes, which is a huge overkill for a CNC machine, but it's nice to have such a possibility. In the first place, I've tried to send a time-based movement segment where each of them had its calculated execution time. This limited the usage of CAN bus, but the entire movement was calculated inside slave units, which led to desynchronization of the axes. I've been fighting this issue for a pretty long time, seeing no results no matter what I change. I've decided to get some inspiration from an existing industrial standard, which is Circos 3. It's a rather complicated communication protocol, but the basis is pretty simple. Circos uses something called a telegram, which is being sent constantly with very high frequency. This ensures the real-time operation of the entire system. This is something I've decided to do in my CAN-based controller. I'm sending a CAN frame with a movement cycle every 1 millisecond, ensuring pretty good real-time operation. This decision finally got me what I wanted, axis synchronization. Now with theory out of the way, let's take a look at what I've used to make everything happen. As the brains of the master and axis slave units, I've used a standard ESP32 microcontroller, mostly because it has a TWI controller built in. I've used ESP32C3 before, but I had to use MCP2515 since C3 has no TWI controller. This led to some limitations like the CAN bus speed. Standard MCP board is not capable of running the CAN bus faster than 500 kilobytes per second. I've used TJA1051 as the transceiver for the ESP32 because the TWI controller itself is not capable of running the CAN bus. You need some kind of transceiver to make it work. For the motors, I've used a simple A4988 stepstick. It's a cheap and easy to operate, and I don't really need anything fancy for now. As you might have seen, I've built a test machine for this controller, a simple 2-axis plotter. With this I could test whether the theory met the real application. I've performed multiple tests of axis synchronization, variable movement speed, homing, jogging, the axes, etc. The most important test was to see whether the axes were synchronized. Without this, the machine would be inaccurate. Instead of straight lines, I'd have arcs. Switching from motion segments to cycle-based operation was a game changer. I was really happy to see I finally could synchronize axes with no issues. I'd probably leave the project for some time if I wouldn't be able to synchronize them properly. In conclusion, I'm sure this is a very good baseline for a modular system where you can add more features as you go. The biggest advantage of this solution is the fact I can add pretty much everything I want. For now I only have access, but if I want to add some kind of buttons, inputs, outputs, actuators, secondary access, screens or human-machine interface, it's very easy to do. I will be able to just add a new node to the system, set its parameters in the master unit, and I'm pretty much done. This project is very complex and there is way more to talk about. In the future I will be adding way more telemetry and diagnosis. I want this system to be alive, where each node is able to define its faults and notify the master unit if something is wrong. The most important thing for now is to not mess up the CAN communication while adding more features. There will be way more videos about this in the future. Maybe I will develop a good and cheap industrial communication standard next to EtherCAT or Circos. Who knows? But for now, that's it in this video. As always, thank you for watching, and I will see you in the next one.